Hi, this is Professor Fernandez, and welcome to Math 205, Multivariable and Vector Calculus at Wellesley College. So one thing I want to do in this video is to just give you a very quick tour of the course and then start the first lesson in earnest. So first thing I'll say is that these are the lesson notes that you can download and access on the website surroundedbymath.com courses. This is a website that I maintain, surroundedbymath.com. When you actually go to this particular link, you will see a big image that you can click on, and it will take you to a Google site that I've created to house all the courses that I teach. On that Google site is where you'll actually find these lesson notes and these videos, practice problems, and a few other resources for the course. So the first thing I want to talk about is a very, very quick tour of the course. This is actually, if I scroll up here, lesson 0. So I call this a very brief introduction to the course because it's basically a page and a half long. I've actually, unlike the rest of the lesson notes, inserted a lot of words and explanations and discussions in here because I would like you to read through this and think about it rather than listen to me talking to you about it. So I encourage you to download this again at the link below. I'm just going to say some very, very quick things here. So in short, Math 205 Multivariable Vector Calculus is about generalizing what we know from single variable calculus to multivariable functions. So what are the three big things we learned in single variable calculus? We learned how to take limits of functions, we learned how to take derivatives of them, and we learned how to integrate them. So in the multivariable context, the word multivariable means we're going to consider functions that have more than one variable. So not f of x, but something like f of x comma y, or even f of x comma y comma z. So in other words, 2 or 3 variables. Sometimes we'll just generalize things to, 35 or however many variables you'd like to deal with. So what's going to happen is a very quick tour again. In single variable calculus, you were used to graphing functions in the xy plane. So here might be a function, y equals f of x. In the multivariable context, specifically in 2 variables, if you can kind of squint here, we'll zoom in a little bit. This is a function of x and y, x squared plus 2y squared. What is the graph of this function? Well, we need 3 dimensions to graph it. We need 1 for x, 1 for y, and then 1 for the output. And the graph of this function actually turns out to be this kind of like cup-shaped shape, which is, somewhat reminiscent of what we call a paraboloid. So in other words, graphing in 3 dimensions is something that we're going to have to learn how to do. Thinking in 3 dimensions, even before graphing, is one stepping stone. We'll do some of that in this lesson. So the second thing is, once you know how to visualize functions in calculus, you start doing things with them. You start finding limits, differentiating, integrating. So here is a picture that gives you a sense of what derivatives will sort of look like. These lines, these red lines here, are kind of like the tangent lines to those blue curves. And using those red lines, you can define what's called a tangent plane. So tangent planes are the analog of tangent lines in single variable calculus. We can also talk about integration. So in single variable calculus, the integral of a function was related to its area or net signed area. In multivariable calculus, the integral is going to be related to the volume or some other measure if the function has more than 2 independent variables. And then finally, we will talk about vector calculus at the end of the course. Vectors basically are objects that, you can visualize them as arrows. They have magnitude and a direction. If you've taken a physics course, or if you've, thought about wind fields, for example, or water flow, then you can think of vectors as kind of the direction and the strength at which something is flowing, be it the wind, a magnetic field, water or stream. So in vector calculus, we try to understand what that can teach us about physical phenomena and about other aspects of math. So we will talk about vector calculus at the very end of the course.